So continuing with 9.1, this is 9.1b, and we are ready for example number 8, which is 4y minus 5 squared equals 6. So again, same old, square root both sides, and we get 4y minus 5 equals plus or minus the square root of 6. Okay, so we keep going here. We're trying to find y. So we are going to get rid of the things that are to the left there with my y. So again, you just write it as plus or minus there, and we'll split them up later. Okay. And one of the things that we've got here at this point is I can't take the square root of 6, so I can't simplify that either. So that's pretty much all I can do. Alright, so one of the things I wanted to show you is when you have a radical, that usually goes at the end. So what I'm going to do is I'm just going to switch my 5 and my square root of 6 around and get that. So we took our plus or minus with the square root of 6, and we just put it on the other side here so that our whole number was first, plus or minus, and it looks like this, and you're done. So this answer, you can leave it like this, or you could write it as 5 plus the square root of 6 over 4, or 5 minus square root of 6 over 4, because of that plus or minus. So that is the actual answer. And the only way you can really find the answer is to find an estimate, is to plug that into your calculator, and 5 plus the square root of 3 and then divide it by 4, and 5 minus the square root of 6 divided by 4, and you get a decimal. Sometimes you're going to want to use a calculator to find out what the actual decimal is, but in this case we're just going to leave it because the solution that we have here is more perfect than a decimal. So this is example 9 again. Okay, so we get that. I'm going to look at that and see if I can simplify it. Are there two numbers multiplied together that give me 8, and I can take the square root of one of them? Yes, 4 times 2. So the square root of 4 is 2, and this 2 right there stays in there. Go ahead and subtract 6 from both sides. And I have 2x equals, I'm just going to put the negative 6 first. Divide by 2. Divide by 2. That gets rid of that. Alright, now sometimes you'll look at this and be like, oh, I'm done. And you kind of are done. But you can also reduce this. Because remember, you can split up these fractions. We haven't done it for a while, but we can split this up into negative 6 over 2 plus or minus 2 square root of 2 over 2. Remember, this 2 is under this, and it's under that. And when we do that, we get x equals negative 6 over 2, which is negative 3. That cancels with that. And that ends up being our answer. Okay? Which is a lot simpler. Alright, so let's look at some applications, and we'll do those in example number 10. So let's see what we've got here. It says here if the shortest side of a 30, 60, 90 triangle, 30, 60, 90. So there's our 90, and there's a 60, and there's our 30. If the shortest side is 1 inch, find the lengths of the other two sides. So we're finding the length of this one and the length of this one. Alright, so what do we know here? A 30, 60, 90 triangle is really half of an equilateral triangle where this is 60, this is 60, and this is 60. And an equilateral triangle means that each of the sides are the same. So if this length right here is 1, the length of the whole side would be 2, which means that's 2, and it means that's 2. So if we're looking at just this white triangle, the short side is 2, this long side is 1, this long side is 2, and all we have to do is look for that side. And what do we know? We know that the short side plus the other short side equals the very longest side. A squared plus b squared equals c squared. Or, let's call A this length, call B this length, so we don't know that length, so we'll just leave it b squared, and we'll call C this length, which is 2. So we have 1 plus b squared equals 4. Subtract 1, b squared equals 3. Square root of both sides, and we get b equals plus or minus the square root of 3. Alright, key thing here. Can length ever be negative? No. So the negative part disappears, and we just have b equals the square root of 3. So for example 11, they give us this triangle. So they've given us the height, and they give us the length of the hypotenuse, or the distance between A and B, and we're looking for that length there. Okay, so using the Pythagorean theorem, a squared plus b squared equals c squared. It doesn't matter what a and b is. We'll say a is this horizontal distance. They call it x. So we'll call it x. So x squared plus 1253 squared equals that length right there, squared. Okay, so all we did was we took the lengths that they gave us and we squared all of them. So this is the one we're looking for. So 1253, let's go ahead and square that. 1253 is 1,570,009. I did that all in my head, right? Okay, and 5,649 squared is 31,911,201. Awful stinking big numbers. Subtract that from both sides, and we get x squared equals 30,341,192. Now we take square root, and that's plus or minus, right? So x equals plus or minus 1. And remember, length can never be negative, so we get rid of that. And we take our handy-dandy calculator, and we plug this in, and click the square root button. Looks like that. And we get a number, and notice my little equal sign changed to a loop-de-loop. This means approximation, because when you put this in there and take the square root, you get a decimal that goes on and on and on forever, and it's not exactly equal to this. It's equal to 5,508 point, yada yada yada, goes on forever. So this little loopy kind of an equal sign means that we are approximating, and you're letting the people know that you're approximating. And so that's pretty much it for 9.1. And I realize I'm not going to go over the set problems. Gosh, I've gone over every stinking problem pretty much in the problem set, just in the examples I gave you. So you should be good to go on this lesson.